Hey class, this video is going to cover section 9.2, which is on page 4 of your notes for chapter 9. It's on linear regression, or another word for that, another name for that, line of best fit. This is the old y equals mx plus b from algebra. Might bring back some memories for you. Really, we're going to be using StatCrunch though, woohoo. Although I do give you the formulas here if you're interested to finding the slope, which we use M for, or the y-intercept, which we use B for. Okay, but those again are just really involved calculations that are kind of tedious, and we're going to, since it's 2020, use StatCrunch. Okay, let's try it. Again, we're going to use the same old StatCrunch feature that you do for all of chapter 9. Okay, so this one we're going to say, find that one, find the equation of the regression line for that systolic blood pressure example from 9.1, the one at the beginning of this packet. So I'm going to go ahead and load that data into StatCrunch. And we'll do it from there. Okay. Here it is. So that was the age versus age versus blood pressure example. So stat regression, simple linear. Age versus blood pressure, compute. Okay, so where that appears is right there. You can see it. Okay. So notice how that is given. It writes out the words for one. So it's blood pressure comma y, which is exactly what I have as my heading for that column. And then it is age comma x, which is the heading for that column. So it's just going to populate the headings of your column. You just got to know that the second column is the y. So when you write this down, you're going to write y hat. I'll show you that in a minute when I'm writing on my handout. Right, and then I have 80 point, let's just go 26, we'll round to 2 decimal places here, should be sufficient, plus 1.71, and then times x is all I'm going to write. I don't have to write age comma x, right? So it will look like just a linear equation that way. Okay, so let me show you a few things, and I'm going to jump back to my handout about that. So really what StatCrunch is giving you are those two numbers, that 80.26 and the 1.71. Now here, notice the way StatCrunch gives it to you is a little bit of a different order. I mean, here's how we typically write it, but you could switch this around, b plus mx, right? That's the same thing. Notice whatever number is attached to the x is the slope. So here my slope is 1.71. And whatever number is by itself is the y-intercept. So in this case, that's the 80.26, right? But if I prefer, I could always switch these around. As long as the x stays with the 1.71, you're fine, right? So you could write it like that as well, okay? And I'm using the hat to indicate that this is a prediction model. A sample or an estimation is what's happening here. Okay. Now where we would use this prediction model is predicting some blood pressures of ages of some men here, right? Maybe we don't have the 55-year-old man in the data set. However, we can still predict their blood pressure using this equation. All you're doing is just plugging the number in, right? So for part A, I have 1.71 times 55 plus 80.26. Okay, and that's a 5. That doesn't look like a 5. All right, that's how I'm using that second version. It doesn't really matter which one you use, right? You're going to calculate it. It's just multiplying 1.71 times 55 and then adding 80.26. Okay, so if I do that calculation, I'm getting 174.31. I would probably just round this to the nearest whole number of 174. The next one then is similar, right? 1.71 times 27 plus 80.26. That's about 126. Okay, so that's pretty straightforward. When I get to this part C, it says predict the blood pressure of an 85-year-old man. If I look back at my data though, let me go back to that data that I'm using here. Was this table. Notice the highest age I have is 70. So this means that for an 85-year-old man, that's sort of outside the range of data for this study. I know we have a linear relationship between these two variables for this range from 16 to 70. It's pretty linear. But, you know, sometimes things are linear and then as x gets larger, it's no longer linear. Maybe it goes, that looks pretty crazy. What happened there? Or it could go up or it could go back down. We don't know. We don't know what happens after that highest point. So we can't make any meaningful predictions well past 70. So if you have any number that's significantly past the highest or lowest value, all you can say is that there is just no meaningful prediction. And I think when you're doing your homework, you have that option as a choice to select it. So select that option if your number that they're asking you to predict is well beyond the data that's given. Okay, so that's one little thing that could happen. Okay. You could also do these in StatCrunch. There's a prediction feature as well. So let me jump back to StatCrunch, and we're going to use that for the next problem anyway. If I start this one over, stat, regression, symbol, select your X, select your Y. If you go down a ways, you'll see this prediction of Y, and you can actually type in the values. Right? So I could type in 55, 27, separating them out by commas. I'm not putting out by commas. I'm not putting in the 85 because there's no meaningful prediction. StatCrunch will predict it, and you don't want to do that. You just have to know not to do it. But I could do the 55 and the 27, and then I get my predictions there. Those will even be more accurate because you have no rounding involved in your equation. Okay, so there's another option. Okay, so let's try this next one about the baseball pitchers. This one's also in your groups folder if you want to play along. So I have my X's and my Y's. If you want to try that one out on your own, go for it. Just press pause and do it. Otherwise, just keep on watching because I'm going to do it. So stat, regression, simple linear. My X is the wins. My Y is the ERA. I've got some predictions. So I might as well throw those in there for part C. There's a 19. There's a 10. The 5 is too low. It's outside the reasonable range of data because the lowest number of wins is 9. So that one's not meaningful, but I could do the 19 and the 10. Okay. this will give me all of the information now that I need for this problem. So for part A, it asks, what is the correlation coefficient? Let's see, that's the R. I've got a negative 0.8878, okay? That, if I interpret that, then that's a pretty strong correlation in the negative direction. So I would say strong negative linear. That's my interpretation. Okay, strong negative linear. What's the equation of the regression line? It's usually the first thing that's given. There it is. So I'm going to write y hat equals, and I'm seeing a 6.49. Let's just do 2 decimals, minus 0.19x. Okay. Another thing that is on your StatCrunch feature, if I click this arrow over, I get the scatter plot. Okay, so there's the raw data, or the dots, and then that red line that you're seeing, that is the line of best fit. Right? It's defined by that equation, y equals 6.49 minus 0.19x. Right? That's the equation of that line. And really what you're finding here, what StatCrunch is finding, is the line that minimizes the distance to these points, right? So the total distance for all these points to the line is minimized for this line here. So that's why it's called the line of best fit. It's your best model, your best linear model, okay? Otherwise, we have our predictions. If we scroll down, for 19 wins, our predicted ERA looks like 2.85. And for 10 wins, 4.57. All right. And then, of course, for 5 wins, there's no meaningful prediction. Okay. That's really it for 9.2. It's all about finding that line of best fit and then using the line of best fit to make predictions. Give it a go, see how you like it, and shoot me questions if you get stuck somewhere along the way. Okay, I'm gonna stop there. Hope all's well. Talk to you later.